Okay, so in the earlier lecture, I talked about interpolation, extrapolation, and then regression. Now, today's lecture, I will start the regression, and under this, I will talk about linear fitting under the topic least square fitting, right? So, this is the experimental data which we have taken, and in this experiment, we have seen the effect of temperature on the length of a wire, because when we heat up a metal, then it expands with the temperature, and generally it expands linearly. So here at different temperatures we have taken the length at different temperatures, right, and we have plotted it. So if we try to look at this, then it's like this. It's not a linear graph, it's like this, right? So we need a equation that which equation fits it. So it's a almost linear graph. So that means there are various possible lines which may be close to it. For example, there are so many lines, and out of these lines, which line we have to choose? That is the question. That which line fits better to given data? That is our requirement. So sorry. So which line suits that we want to determine here, and for that we have to understand that what is a line. So line is generally characterized by, or if I recall the equation of line, so equation of line is, which we have studied, because we want to fit a line for this experimental data. So equation of line is equal to y is equal to mx plus c. Here y is the slope of the line and c is the y-intercept. So for different lines, m and c will be different. So that means we need m and c such that line best fit the data. Means it is more closely to our experimental data. So this is our purpose. So that means a line is characterized by its slope and the y-intercept. So our purpose is to find out the slope and this y-intercept. This is our objective. So for this, let us do one thing. Say there are some experimental points I am having. So these are the experimental points, say, and let us assume that there is a line of best fit for this data is this one. This is the line of best fit, right? That's what I have assumed. So say this is x1, y1, and it is x2, y2, x2, y2, and it is xi, yi, and so on. These are so other points we have also listed here, and I have assumed that this is the line of best fit. This is assumed that this is the line of best fit. And let us assume that its equation will be y is equal to a plus bx. Here a is the y-intercept and b is the slope of the line. So that means, let me call this as f of x. Now, corresponding to every xi, there is yi and f of xi, and this f of xi is a plus bxi, and this is from the chosen line which we have chosen. This is the experimental point. This is also chosen point, right? So, but for a particular point, there is a value of y, and this is the value of that function corresponding to that point, right? Means we are having x1, y1, and f of x1, x2, y2, f of x2, and so on, xi, yi, and f of xi, and so on, right? So that means if this point is yi, and corresponding to this xi, there is a point over this line. This point is known as f of xi. So that means there is some error between the experimental value and the point which we have chosen on the line. There is some error, and this error is basically represented by qi, and this qi is basically yi minus f of xi. This is the error. Now, this yi is from experimental data, and this is chosen from the line, chosen from the equation of line, right? This thing which we have to keep in mind. Let me call this as equation number 1. So this error, so that means it is yi minus a plus bxi, or it can be written as yi minus a minus bxi. Let me call this as equation number 1. Similarly, we have to decide all the errors. If I choose all the errors, then all the errors can be calculated like this: minus yi minus a minus bxi, where I varies from 1 to n. But another thing which we have to keep in mind, sometimes, because some points are lying below this line and some points are lying above this line, so due to this, a possibility is that this error may become 0, but it doesn't mean that it must have error. It doesn't have any error. So for that, what we do, we will take their squares. So that means, that's why we call it as least square method, right? So that means rather than taking its square, but we will take the square of the errors and taking their sum. So that means qi square, we will take it as, and let us call it as q, and I varies from 1 to n. We have to determine rather than q, but we will rather than the sum of the errors, but sum of the squares of the errors, right? It is basically sum of square of errors, and this must be least, but let me talk about that later on. So let me define it. So that means it is yi minus a minus bxi whole square, and summation I varies from 1 to n. this is the value of the q, right? Sorry, this is equation number 3, and from here I can calculate qi square, and qi square can be written as yi minus a minus b xi whole square, right? And then taking sum of all such errors is this way. From here I can calculate this, and using this I can calculate sum of all, and let me call their sum as a capital Q. Now our objective is to determine A and B such that this Q is least. Means we need a line for which slope and intercept are chosen in such a manner such that this Q should be least. So that means Q is basically a function of A and B. This suggests that Q is a function of A and B, and for the given experimental data xi and yi are constant. So to minimize this Q, what we need, we have to take the derivative of Q with respect to A. It should be equal to least, and Q with respect to B, it also should be equal to 0. That's what we have to do, right? Then we will get the relationship for A and B, and so that that can be calculated. So first of all, let me try to calculate curly Q over curly A is equal to curly over curly A, and it is summation yi minus A minus B xi, its whole square, where I varies from 1 to n. And let me open it up. So it is curly over curly A y1 minus A. Let me open this summation. Vx1 whole square plus y2 minus A minus B x2 whole square plus, and so on. And if I take their derivative, then it must be equal to twice of y1 minus A minus B x1, and then it is derivative with respect to A. So if I take its derivative with respect to A, so minus 1 will be there. So I will write down that minus 1 here. So into 2, then its derivative in the similar manner, and so on. So that means minus 2 can be taken outside, and I can write down this in the form of a summation. So it is yi minus A minus B xi. That's what I am getting, right? Let me equating it equal to 0 because we have taken it equal to 0, and say it is equation number 5. Now I will calculate curly Q over curly B. Curly over curly B, yi A minus B xi whole square, summation I varies from 1 to n, right? And let me open this again. So it is curly over curly B y1 minus A minus B x1 whole square plus y2 minus A minus B x2 whole square, and so on. And it's equal to y1 minus A minus B x1, and its derivative will be minus x1 because I will apply the chain rule here. So it is minus x1 plus twice of y1 minus A minus B x1, minus x2 and so on. It's minus 2 can be taken outside and writing it as in the form of a summation again. It is xi into yi minus a minus b xi, right? That's what I am getting, and it is equal to 0. Let me call this as equation number 6. And let me now consider the equation number 5. When I consider equation 5, then I can write down that as like this: yi minus a b xi, and where I varies from 1 to n, it is equal to 0. Minus 2 is not equal to 0, which implies that this part must be equal to 0. So summation I varies from 1 to n yi minus a minus b xi equal to 0. Let me open this summation part, right? So if I open it, so I am getting y1 minus a minus b x1 plus y1 minus a minus b x2, sorry, 2 will be there, plus y3 minus a minus b x3 and so on equal to 0. So that means y1 plus y2 plus y3 and so on, minus a plus and so on, taking it n times, minus b x1 x2 and so on xn, n terms are there, and it is equal to 0. So I can write down it as summation yi minus na, because they are taken n times for every term. From every term it has been taken, so it is minus b summation xi. I varies from 1 to n. I varies from 1 to n. It is equal to 0. So from here I can write down that summation yi is equal to na plus b summation xi, and let me call this as equation number 7. Now considering equation number 6, so if I take equation number 6, then that equation is like this: minus 2 summation xi yi minus a minus b xi equal to 0, where I varies from 1 to n. So it can be written as minus 2 is not equal to 0, but rest of the part, and I will try to simplify because xi gets multiplied inside it. So I can write down that this I is equal to 1 to n. It is xi yi xi a minus bxi square, and it's equal to 0. Let me open this summation, this part, because this is equal to 0. So taking this part, so it is x1 y1 ax1 minus bx1 square plus x2 y2 minus ax2 plus bx2 square and so on, it is equal to 0. So I can separate the terms. So first of all, I will take x1 y1 plus x2 y2 and so on, then minus a x1 plus x2 and so on, minus, sorry, this is minus b, right? So I've forgotten it. So it is minus b x1 square plus x2 square and so on, it's equal to 0, means I can write down it as xiyi minus a summation xi, I varies from 1 to n, I varies from 1 to n, minus b summation xi square, I varies from 1 to n, and this is equal to 0. So from here I can write down that summation xiyi is equal to a summation xi plus b summation xi square, where I varies from 1 to n, I varies from 1 to n, I varies from 1 to n, and let us call this as equation number 2. Sorry, equation number 8. Right. So now we are having two equations, equation number 7 and 8. Let me recollect those equations. Right. So summation, NA plus B summation xi is equal to summation yi, and here A summation xi plus B summation xi square is equal to summation xiyi. This is equation number 7 which we have written, and this is the equation number 8. Now our objective is to calculate A and B. First of all, I will find out the value of B, and then I will use that to find out the value of A. So these are two simultaneous linear equations. So, and variables are A and B. So I can write down A, B minus 1. So for A I can do like this, and then this like this. So for A I have to take an summation xi, summation xi square, summation yi, summation xiyi. This is equal to summation yi, summation xiyi, and here it is n and summation xi, and is equal to, it is n summation xi, it is summation xi and summation xi square. I will calculate the value of B from this part. So from here I can write down that B upon summation yi summation xi minus n summation xiyi, it must be equal to minus 1 upon n summation xi square minus summation xi into summation xi, right? So I have not written here that summation varies from 1 to n. It is understood. So from here I can write down the value of y. Sorry, not y but b. So b can be written as, this goes to that side, so it is minus summation yi summation xi minus n summation xi yi upon n summation xi square minus summation xi whole square. Multiplying with this negative sign, I am getting this positive and this negative, so it is n summation xiyi minus summation xi summation yi whole upon n summation xi square minus summation xi square whole square, right? So it is the value of V which I am getting. Let me call this as equation number 9. Now using this P, So now from equation 7, we can write down that summation yi is equal to na plus b summation xi. So from here I can calculate this a. So na comes out to be na is equal to summation yi minus b summation xi. So from here I can write down summation yi by n minus b summation xi over n. So that means this is the relationship for b, a, that can be calculated in terms of b. So from here I can use the value of b from here, and then using 9 and 10, let me sum up these two results, or need not to sum up, but using this 9 and 10 we can calculate a and b, right? So this is the method of least square fitting. So once we know the values of a and b, we can do the experiment, right? Sorry, we can do the calculation. So these are the two formula which we have to remember, right? So that's all for this first part. Now in the second part of this I will do the same problem. So our equation is y is equal to a plus bx. So in place of y we are having length, and in place of this x we are having t. So let me do one thing. This is, and what is needed, if I recollect the equations, then b is equal to n summation xi yi minus summation xi yi, sorry, then whole divided by summation xi square minus summation xi whole square, and this a is equal to summation yi by n minus summation xi by n multiplied by b. So that means what is needed? We need summation xi, we need summation yi, we need xi yi, and we also need summation xi square. These four things which we have to determine, right? So for this, let us do a little calculation, and in place of x we are having t, and in place of y we are having l. So that means it is the serial number. So 1 observation, 2 observation, 3, 4, 5, overall 6 observations we are having. So here it is 20, it is temperature 20, 30, 40, 50, 60 and 70, and let me call it as Li, and it is Ti, and it is Li, it is 800.3 and 800.4, 800.6, 800.7, 800.9 and 801.0. That's what we must know. Now let me write down Ti square, and here it is sitting in place of x, and it is sitting in place of y. So now I need Ti square means xi square. So Ti square, it can be written as 400, 900, 1600, 2500, 3600 and 4900. And after that I need TILI, means both gets multiplied. So TILI, so TILI is this one. Here it is 24012, 32024 and 40035, and it is 48054, then it is 56070, and I need to calculate their sum also. So for that I will proceed as follows. Means I need to sum up all the values. So let me sum up these values. when I sum up, here this is summation Ti, here it is summation Li, here it is summation Ti square, and here it is summation Ti Li, and let me write down their values. This is summation Ti is 270, its value will be 480.3.9, and its value will be, their sum is, it will be 13900, and their sum will be 216,216,201, right? This is their sum. And another thing which we need, that we need to calculate Ti Li, that is also needed, right? So that means we have to multiply these two. So their sum is basically 1297053. This is their sum, right? That's what we are getting. So I will put these values in the given formula. So for that, let us proceed as follows. So the value of B will be, this B is equal to n summation Ti Li minus summation Ti summation Li whole upon n summation Ti square, and these are overall 6 observations, so n will be 6, minus summation Ti square, and the value of A will be summation Li over n minus B summation Ti over n. So let me do calculation for B. So it is 6 into 216,201, it is their values, minus 6 into, its value will be directly written from here. So 1297053 whole divided by 6 into 13900 minus 270 whole square. And if I do this little calculation, the value which I am getting, the value of B comes out to be 0.0146, and if I put their values here, this value here, and use all these, because summation Li, as I know that this summation Li is basically 4803, so it is 4803.9 upon 6 minus, and the value of B will be 0.0143, sorry, not 3, what, 6, and into summation Ti will be 270, so it is 270 upon 6, right? Yeah. So this after simplification is 799.993. These are the values which we are getting. So thus, once I know their values, let me write down their values. The A which I am getting is 799.993, and the value 0.0146. These are the two values which we are getting. So that means the equation of line will be L is equal to A plus PT. So that means this L is equal to this one, so it is 799.993 minus plus 0.0146 into T. This is the equation which we are getting. This is the equation of best fit. is the equation of best fit. And this is a line, right? So let us do one more thing, little analysis of this. So we have values of Ti, we have values of Li, and this is from the experiment. This is from experiment. And another is the line A plus B Ti, or it is equal to 799.993 plus 0.146, sorry, 0.0146 into Ti. So if I know the values of T, because this is known, so it is 20 degree, it is 30 degree, it is 40, 50, 60 and 70. So corresponding to 800.3, here it is 800.4, 800.6, 800.7, 800.9 and 801.0. And if I put these values in this equation, then fitted values will be 800.285, 800.431, 800.577 and 800.723, 800.869, and here it is 801.015. These are the values which we are getting. Now what I did, I have plotted these values. So if I plot these values, the result which we are getting, let me do one thing. Yeah, so I have fitted these things in the graph because this is the data which I have taken. Yeah, this is the data which I have chosen here. Right, so these are the data points, and then I plotted these using XM Grace. So I've used the XM Grace to plot it. So yeah, this is the fitted data which we have to keep in mind. Yeah, this is the graph. So this is the experimental data. This is the black points, and this is the fitted line. So I have plotted it using the XM Grace. So that's all. So this is a very simple example which I illustrated here to find out the line of best fit. Just that's all for this lecture. And in the next lecture, I will talk about the curve